Hey guys, welcome to the level 2 calculus exam from 2022. If you're joining us for the first time, the way this video works is that I go through each of these questions one at a time and tell you guys what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, have a go by yourself, and then unpause the video to have a look at what I've done. So without further ado, let's get started. Okay, so with question 1, what we've got here is just differentiate and find the gradient when x equals to 3. So just going to differentiate it first. We've got f dash of x is equal to, we got 8x cubed plus 12x squared minus 40x, and of course the 5 just disappears, and we're trying to figure out what the gradient is when x equals to 3. So we're going to substitute x equals to 3. So we've got 8 times 3 cubed plus 12 times 3 squared minus 40 times 3. So just working that out real quickly. We got 8 times 27 plus 12 times 9 minus 120. Okay, so we've got 204, and the answer schedule basically just says that you need derivative found and gradient evaluated. So to get an achieved, you kind of need to do both of these steps here. Okay, so achieved for that question, and moving on to the next one. So next one, we've got an integrate. Well, we've got to integrate it because we've got a gradient function. And it passes through 3, 4. Alright, so I'm going to write down the equation first. So 4 minus 6x plus 2x squared. When I integrate this, I am going to get 4x minus 6x squared over 2 plus, I've got 2x, let's try that again. 2x cubed over 3, and of course don't forget the plus c. That's really important. Now it says that it's actually going to go through 3, 4, and because it's going to go through 3, 4, we're going to substitute in. So just another way of writing this is we can actually write this as f of 3 is equal to 4. So I'm going to substitute it in here. 4 is equal to 4 times 3 minus 6 times 3 squared over 2 plus 2 times 3 to the power of 3 over 3 plus c. Putting this all in the calculator, but I might just kind of make it a bit simpler first. That's going to be 27. 9 minus that. If I made a mistake, no, I've not made a mistake. It is 3 cubed, but 3 squared plus 9 plus 18 plus c. I mean, you guys can do this easily on the calculator, but you know, I'm just being a bit lazy at the moment. I don't want to type all of that in there. So 4 is equal to 3 plus c, and c is equal to 1. So we need to write down the equation. So the equation f of x equals to 4x minus 6x squared over 2. I mean, you could have put that as 3x squared. 2x cubed over 3 plus 1. This question is worth only an achieved. I wouldn't expect anything else because it's a straightforward standard integrate the question and find out what the c value is. Okay. So, question C. Calculus to find the values of when this function is decreasing. Okay, so remember that when a function is decreasing, that means the gradient is actually negative. So that's the first thing you need to kind of understand here. So when it says when its function is decreasing, we put f dash of x less than 0. So basically, when is all the gradient negative? When the function is increasing, we say that the gradient is greater than 0. So all we really have to do is differentiate and put it less than 0 and try and work out what that limit is. Now if you did MCAT, well, you would have done MCAT last year. We did a lot of these types of questions where when is the parabola under the curve and over the, like under the curve, under the line, or negative or positive and stuff like that. If you go back and have a look at those videos, you'll kind of start making connection with this. But the reality is that this type of question is not going away. It's going to come back at differentiation for level 3 as well. Okay, so first thing we're going to do, f dash of x. F dash of x is going to be 2x, the 3's cancel out, so 2x squared plus 3x minus 20. So that is actually step 1. Then we've actually got 2x squared plus 3x minus 20 is actually less than 0. Now, there's a couple of ways of doing this. The first method is obviously, I mean, if you have a graphics calculator, you can just pull out those numbers straight away and move on. But let me show you guys how to do it in the graphics calculator first, and then I'll show you guys how to do it manually as well. So in the graphics calculator, there's a couple of ways of doing this. You could do the graph method. So just plot the graph as it is. So you're going to get 2x squared plus 3x minus 20. Now, you know that this graph is a positive parabola, so it's going to look like this. And we want to figure out what those 2 points are. So it actually tells us when is the gradient actually negative. So I could go option, no, not option, G-solve, no. Let's try G-solve. And we're looking for the roots. So there's my first root, which is at -4. And my second root, which happens to be at 2.5. Now, you don't really need to show any kind of working here because you've got those 2 points and you can kind of see that the parabola is negative between those 2 points. So if I was to sketch it, so here is the parabola right now. And my 2 points are -4 and positive 2.5. And if you look at it, the part where it's actually less than 0 is this part here. So I could actually write my answer straight away as -4x and 2.5. Pretty much that gets you a merit for that, right? And for the achieved part of this question, this is where you're getting achieved, and this is where you're getting merit. Now, if you don't have a graphics calculator, a couple of ways you can do this is by putting the quadratic formula and getting the 2 values. So what you would do is from this step, you would actually go on to go 2x squared plus 3x minus 20 equals to 0. So your first thing is you could actually use quadratic formula to figure out what x is. The alternate method, you know, the kind of like the weird algorithm method, which I'm going to show right now, is basically going, what do we got? 2 and -20, which makes -40. And I'm looking for something that multiplies to -40 and adds to +3. So that's 8 and -5. So then I rewrite the quadratic as 2x squared, and use my red pen there, plus 8x minus 5x minus 40. Then I've got to split them up, so into 2 parts, and I've got 2x and x plus 4. And in here I've got something is not right. I've made a mistake. Right, I know where my mistake is. That should have been 20. I guess it's a good way of doing doing this method. It's like you can kind of pick up where you make your mistakes. So -5 is a common factor, and I've actually got x plus 4. Now x plus 4 is a common factor, so take it out, and I've got 2x minus 5, which is the leftover parts here. So the 2x comes from there, and -5 comes from there. So the next part is, of course, remember that this is equal to 0. So I've got x plus 4 is equal to 0, which gives me the first interval, start of the interval, which is -4. And then I've got 2x minus 5 equals to 0, So 2x is equal to 5, and x is equal to 5 over 2. So x is equal to 2.5. So pretty much what I've done here is I've figured out my two intervals, and then I got to go back to this step and kind of work it out. So I guess, yes, there is a massive advantage to having a graphics calculator, because you can actually do some of these questions without having to do all of this working, which just saves you a lot of time when it comes to the exam itself. So, and of course, like if you look at the answer schedule, like they don't really show all the factorizing part. They just kind of show that this part, which is, you differentiate, put it less than 0, and then you just get the answer straight up from the calculator. All right, so let's go to the next question. So in here, I've got f of x, which is px minus qx squared. It has a point to -10. So we can actually say f of 2 is equal to -10. And it also has a gradient of -6. So we've got f dash of 2 equals -6. Now there's a reason why I wrote it like that, because you can kind of see they're asking you to find the values of constants p and q. So, and we've been given kind of like 2 bits of information, so it's pretty obvious we're working with simultaneous equations, but we'll get there. So the first thing is f of x. Now we know that f dash of x we can differentiate here, and we're going to get p minus 2qx. So that is your derivative. Now, and then what we can do is we can actually do f of 2 is equal to -10. So we can say that -10 is equal to, now remember, for f of 2, we're going to be using f of x. So that formula that we're going to write down. So we're going to write that formula down first for f of x, because f of x is equal to p of x minus qx squared, which means -10 equals p times 2 minus q times 2 squared. So in other words, we can say -10 is 2p minus 4q. So that's one equation. Now we're going to look at our second equation. So f dash of 2 and f dash of x. So f dash of x is equal to p minus 2qx. So we've got -6 is equal to p minus 2q2. So we've got -6 is equal to p minus 4q. So because we've got that, we've actually got 2 simultaneous equations. I'm not going to use the graphics calculator for it, because I'm looking at this question here, and I can kind of see it kind of nicely eliminates itself, particularly the q part here. So I've got -6, I've got an equals. That's the problem. -10 equals 2p, -6 equals p minus 4q. All right, so what I'm going to do is I'm going to subtract one equation from the other, which means I've got -10 minus -6, 2p minus p, -4q minus 4q. So when I subtract it, -10 minus of -6, which is, I'm doing it here. So -10 minus -6 is -4. The equal sign stays as it is. Then I've got -2p minus p, which is equal to p. -4q minus -4q will become 0. So I've actually got p is equal to -4. Once I get p equals -4, I go back and substitute it in. I can use any equation. I'm going to use p minus 4q. So I've got -6 equals -4 minus 4q. Bring the -4 to this side, and it gives me -4q. I've got no, that should be positive. So I've got -2 is equal to -4q, and q is equal to -2 divided by -4. So q is equal to 0.5. So grades wise, correct solutions for both P and Q found is excellent. So I might just put that here. P is equal to -4. So finding both of these solutions gives you an excellence. 2 linear equations found could be merit, which is up to here. Substitution used to eliminate either P or Q. Now, if you find one of these things, you will get a merit. For achieved, oh wow, really? Derivative found and substitution of x into f dash of x. And f dash of 2 equals -6. I'm going to have a look at the answers. So I'm looking for the achieved. Achieved derivative found and substitution of x equals to 2 into f dash of x and f dash of 2 equals -6. I get a feeling that they were supposed to say f of x. But if they were meant to say f of x, because that's a lot to do for an achieved. But you know what? That literally means like basically you've got to do all those steps above the green line to get an achieved. But they're not really worried about f of the middle part of it, where I did f of 2 as -10. But anyway, it's to be honest, it's not a crazy excellence questions. You know, I've seen far more crazier ones than this one. This one is actually a nice excellence question. Okay, so let's go to the next one. Talk about crazy excellence questions. Well, actually, this is not too crazy. This is just one of those weird questions. Once you put everything together, it'll kind of make sense. Okay, so blah blah blah. Now, let me put it this way, right? Like this type of question, you know, I'm looking at the part 1 of it where it says find the maximum area, and straight away I kind of know that I probably will be given some sort of length and I've got to come up with an equation. And you know, my eyes just go straight into this 80 centimeters there. But have a look at it. It's basically the total perimeter is cannot be greater than 80 centimeters. So this distance here cannot be more than 80. All right. Now it's asking you to find the maximum area. So what we're going to do is we've got to come up with an equation. Now the first thing I'm going to do is I'm going to get rid of this here for now, and I'm going to put a little h here for the height. Now I don't know what that h is, but I'm going to put h there. The other part of it is I'm going to put that little part there as r. So if you look at it, I've actually got a rectangle and 2 semicircles that I've got to take away. So that's what I'm going to do here. I'm actually going to write this rectangle minus the 2 semicircles. So there's a semicircle at the top and there's a semicircle at the bottom, equals to kind of like this shape. And I hope that kind of makes sense what I've just done there. So if you have a look at the dimensions of this is going to be h and r, 2r actually, and the circle is going to be pi r squared, half pi r squared, and then there's another half pi r squared at the bottom. So my equation for this area is equal to h multiplied by 2r minus pi r squared. Now remember, it's actually pi r squared because there's 2 semicircles, and it's when I put them together I'm going to get 1 circle. So that's my initial equation. My second equation that I've got to come up with, because this is a classic optimization question, right? The second equation that I've got to come up with is the 80 and the yellow border. So if you look at it, I've actually got h, and I've got circumference of a circle, because I've got half a circle for circumference here, and the other half is there. So basically, the yellow border that I've done is equal to 80. So I could actually say 80 is equal to 2 times height plus the circumference. Now the area, the formula for circumference is 2 pi r. And I think they do give those. Did they give those formulas? I thought they did. Yeah, they do. They give it at the bottom of the next question, which is a bit annoying. No, it's not. Sorry. The way the question is set up is that part 2 comes straight after this. So you could actually have a look at the two formulas. So with 80 equals to 2h plus 2 pi r, what I'm going to do is I'm going to write h in terms of r. So this is going to become 80 minus 2 pi r equals to 2h. And then h is equal to 80 minus 2 pi r divided by 2. So I can rewrite this as 80 divided by 2 minus 2 pi r divided by 2. So h is equal to 40 minus pi r. Now once I get h equals to 40 minus pi r, what I then do is I actually substitute the h into my original area equation. So when I do that, I'm going to get area equals 40 minus pi r multiplied by 2r minus pi r squared. So a is equal to 80r minus 2 pi r squared minus pi r squared. So I'm going to get my area equation as 80r minus 3 pi r squared. And at this point, I've got to differentiate, put it equal to 0. So I've got a dash is equal to 80 minus 6 pi r. So once that happens, I actually need to figure out what the r is. So I'm just going to write a little statement. A dash is, so hang on. What am I going to put? A dash is 0. How much space have I got? Oh, I've got not much. Okay. So if a dash is equal to 0, so I can put down 0 is equal to 80 minus 6 pi r, and I've got 6 pi r equals 80, and then r is equal to 80 divided by 6 pi. Now this is just the radius when the maximum area happens. I still need to figure out what the maximum area is. So to do that, I need to take it back to the original equation, which is 40 minus pi r. Because I've got everything in r, I'm just going to get rid of the h, don't worry about it, times 2r minus pi r squared. So remember that h is equal to 40 minus pi r. So because I don't want to find h and then substitute it again, it's just too much work. So here I've got 40 minus pi times 80 over 6 pi times 2 times 80 over 6 pi and minus pi times 80 over 6 pi squared. That's a lot to put in the calculator, but it shouldn't be too bad, because what I'm going to do is I'm going to run a little shortcut here. I'm going to use the answer function. I mean, I've shown you guys how to use the store function as well before. If you do want to know how to do that, you can check out one of the graphics calculator playlist videos. It shows you guys how to store a variable, but in this case I'm just going to use the classic answer function, just because sorry. So 80 divided by 6 pi, that is my number. So I've got in bracket 40 minus pi r, so pi times answer, then multiplied by 2 times answer minus pi answer squared. So that gives me an area of 169.77 centimeters squared is what we want there. Now, this is one of those weird questions, right? Because it actually has a second part to this question. And and I kind of copied it there, but basically the second part of the question actually says use calculus methods. Where did it go? Use calculus methods to show that this is a maximum. All right, so I'm kind of do that question here as well. So it's all done in one place. But basically, if you want to figure out something that's maximum or minimum, I always run the second derivative test. So I've got a dash is equal to 80 minus 6 pi r. So when I run a double differentiation, I'm going to get a is equal to negative 6 pi. And at this point, you can actually say second derivative is always negative. Therefore, always negative. Therefore, it is a max. And that's pretty much what you need to do for this question. In terms of excellence grades wise, justification from. So you need to do the justification part to get an excellence. Either you could actually do like a trial with the gradient functions, but second derivative is always easy. So again, have a look at some of my videos. If you just search up second derivative on my channel, you'll find it. It's super fast than trying to do the gradient method. For merit, you need a dash equals 0 and solves for r. So you're looking at merit up to here. And for achieve, sets up area and differentiates. So achieved is there. That is what's going to get you an achieved. So, you know, it's not a bad optimization question. It's actually fairly decent once you put the equations together. And I think the best way to do all of that is just draw those diagrams and start sketching out those letters, and it should start making sense. All right, guys, that's question 1. Let's move to question 2. Question 2a. This question here, personally, I find this question annoying because normally when they put a question at the start, they don't put that as an excellence question. They usually put it as an achieved question. And, you know, when I look at this particular question, the first thing I'm thinking is that, oh, it's a cubic. And I can see, you know, like, and I'm glazing through it. And I was like, oh, function f of x is that. So you probably asked to draw a gradient function below it. But really, the most annoying thing about this question is that what they've done is they've actually done the gradient function. And then they are asking you to find the original function, which is kind of stink. Because, I mean, if you think about it like this, right? Now, this is a cubic here, which is an x cubed. But this is the gradient function. So if you want to find the original function, you're going to have to integrate this, which means you're going to get x to the power of 4. Now, I don't even know if some of you guys have actually seen what this graph looks like. It kind of sucks that they put it in this one, but, you know. Basically, x to the power of 4, because it's upside down, it looks like a kind of like a weird looking W kind of shape. That's what this graph is for x to the power of 4. So that's what you've got to try and do. Now, I always kind of struggle with this part of it because it's just, I can never get the line. Yeah, it's slightly off. It's not straight because I couldn't actually put it underneath each other, but you get the idea. Like if I go negative, I can't even see where the points are. What? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I guess it's in the middle. So what I would do is I would actually put down these lines at -3. Then I've got one at -1. And then I've got somewhere between looks like 3.5. Yeah, sorry guys, it's not lining up perfectly, but you get the idea. But basically what I'm trying to do is I'm trying to join those lines I think I pasted it slightly wrong. So anyway, that is the kind of like the important parts. And what you kind of need to do is shift this graph into this with those peaks. So those 3 blue lines, the light blue lines, 1, 2, 3. So it's actually going to happen when it's the maximum and minimum and so on. All right, now we don't really have any other information. The only other information that we have is that if you look at, if you actually look at the gradient, like what am I going to say? The slope itself, because the top graph is actually telling you what the slope is. Now the slope is getting quite steep here because the number is actually quite high. So that means that you're going to have like this really big hill, and that's actually shown here. So all you really need is just this rough kind of diagram where it goes through this. Now I don't know if I'm going to get excellence for this, but I'm just going to give this a crack. Obviously I don't want to do all of that as well, so I just want to make sure I get that nice curve at the top and kind of bring it around like that. Now what I'm going to do is I've just drawn a rough sketch here, but I've got the answer schedule and we're going to just double check whether our answer actually makes sense. Now I just kind of roughly sketch that out, right? So the answers itself, it looks something like this, but I'm not worried about the shape as much. I'm more worried about this and to see if I can get all of that. So the first thing that I did was that, okay, so is this got the blue shape? In my one, yes it does. It does have the blue shape, so that's good to know. So definitely I'm going to get an achieved for that. Now weirdly enough, for this question they've actually given you merit if you were to do it as a parabola. So if you say you make a mistake as a parabola, it says if axis is not labeled and an inverted parabola is drawn. Yeah, so this is basically like looking at the question and going, oh yeah, I saw it wrong, and I decided to actually put a parabola because I draw the derivative of it. So it's and I think they give it to you up to merit as well, which is pretty kind of them, because I have a feeling that a lot of kids would have actually got that question wrong, and I'm guessing they probably would have changed the schedule a little bit. That's why these extra 2 little notes are there. Negative quadric shape with turning points lined up with x-intercepts, gradient graph, which we did that. So it's -3, -1, 3.5. So if we actually go to my one, those are those 3 blue lines, -3, -1, and 3.5. So that's all good here. And then finally local max at 3.5. So it has a higher y value than the local max at 3 because of the gradient shape. So that's here. So you can kind of see this is my local max 1 and 2, and obviously the one at 3.5 is actually much higher. So as you guys can see, like that is pretty much what we're looking at for excellence. Yeah, so it's I just think it's just very mean to actually have a question like this at the start of the exam paper, when start of a question most people think that it's going to be an achieved and kind of start doing things real quickly. Because even myself, right, I've done these questions so many times. I looked at the question and I went, oh, that's a pretty straightforward derivative, and then I went and checked the answers and it was the other way, and I was like, what? Then I read the question properly and I went, oh wow, this is just really, really mean. Because like, look at this, the first thing I see is that f of x right there, and so straight away I don't even read this part, the gradient graph, because I just go, oh, it's f of x. Okay, so that means I'm doing derivative. And so yeah, it's kind of sad, but anyway, we move on. So the second question here, what we got a height. Find the maximum height that the ball actually reaches. So we've got h. We're going to figure out what h dash is. So h dash is equal to 22.5 minus wrong pen, minus 4.9, so 9.8 t, and we are going to leave it like that. Now we know that max happens when h of x is 0, so we're just going to write that down here, or h of t actually. Well, it doesn't really, well, I mean, yeah, it should have been h of t, not h of x, but I'm actually going to put that as h of t. So we've got 0 is equal to 22.5 minus 9.8 t. So 9.8 t equals 22.5, and t is equal to 22.5 divided by 9.8, and that is going to give us the time. Which is 2.296 seconds. So remember, this question is actually asking us to find the maximum height. So we need to go back to the original equation and substitute it in. So 22.5 times 2.296 minus 4.9 times 2.296 squared plus 1. I'm going to use the answer function again. So 22.5 times answer minus 4.9 times answer squared plus 1 gives me 26.83 meters. So h is equal to 26.83 meters. Now in terms of grade for this question, you are going to get merit for finding the height. Derivative find and put it equal to 0 is going to get you an achieved. Okay, next part, next question. So the next question, it actually says P is the number of people, T is time. Now it says show that the rate of change of spectators is minus 528 when T is equal to 6. So all we're doing is differentiating it and put T equals to 6. Differentiate P. So P dash is equal to 200T minus 8T cubed. And then we're just going to put it as 6. So P dash of 6 is equal to 200 times 6 minus 8 times 6 cubed, which is, let's just do this in the calculator straight away. So which is 1,200 minus 8 times 6 to the power of 3, which actually gives us minus 528. This is one of those, again, this is one of those weird questions where it's like 3 parts to it, and each of the parts is actually worth a grade. So I think this first part is actually worth, and I think you only get 1 grade for it. So if you guys have a look at the answer here, the schedule basically says part 1, part 2, part 3, and you actually get like, yeah, those 3, kind of like you get the maximum grade from that question. But anyway, so we've got P is equal to minus 528, dp dt found, and T equals to substitution. Right, so this is actually going to get you an achieved. Let's go to the second part of this question. Second part of the question says, what is the meaning of this value for the rate of change? Because basically what we had was minus 528. All you have to write is it means 528 people are leaving the game at that time. So this interpretation is going to get you a merit after you did that achieve part, of course. But see, I guess this is kind of really weird, but no, I think you have to actually show the achieve part because it actually says and let's go to the last part of this question. It actually says another match. You've got P equals to this. Number of spectators is growing fastest when T is equal to 4. So this one is a little bit more little bit different, right? Because what we have got is we got to figure out what p dash is first. When we work out what p dash of t is first, we're going to get 2kt minus 8t cubed. But here's the thing. If you look at it, the number of spectators is growing fastest when t is equal to 4. Basically, that's actually telling us that the gradient function is maximum when t equals to 4, not the function itself. That means you need to differentiate it another time, because if you want to find out when is the gradient the maximum, that's the rate, the rate at which something is changing, right? So the gradient, when the gradient is maximum, you've actually got to go differentiate it twice and put it equal to 0. So I'm actually going to put down p double dash of t equals 2k minus 24t squared, and then p double dash of t is equal to 0 when p dash of t is max. Now I hope that makes sense, because normally what we do is we get a function, we differentiate it and put it equal to 0 to find what the maximum point of that function is. But in this case, because we're looking at when is the rate, the rate of number of spectators is growing faster. So that's like saying the gradient is the max. So that's why we differentiate it twice and put it equal to 0. So we've got 0 equals 2k minus 24t squared. Rearranging this, we've got 24t squared equals 2k, and we're trying to find k actually. Oh, right. So k then is equal to 24t squared divided by 2, and k is equal to 12t squared. So the reason why we put this as k equals to 12t squared is because but we haven't figured out what the k is. Oh, but of course, number of spectators is growing fastest when t is equal to 4. So that means I've actually got to go back and substitute k, sorry, not k, t as 4, and I'm going to get 12 times 16, which equals to 192. That's better. K is equal to 192. So grades wise, you've got to do both of these things, which is you've got to do this and this, and you end up getting excellence. Now, if you actually don't attempt this question at all, you could get an achieved for p double dash, and you could also get a merit possibly for this question if you do p double dash is equal to 0. So that part there could get you a merit, and this part here gets you an achieved. Okay, cool. That's basically it for question 2. We move to question 3 next. Alright guys, so with question 3, what we've got here is we've got equation of tangent. So find the gradient and then put it into equation of a line. So I'm going to put down f of x is equal to, expand the brackets first. I've got 2x squared minus 3 6x, which means f dash of x is equal to 4x minus 6. I need to figure out what the gradient is. So the gradient at f dash of 1 is 4 times 1 minus 6, which equals to -2. I also need the point f of 1, which is equal to 2 times 1, 1 minus 3. So f of 1 is equal to, what do you got? 2 times -2, which equals to -4. So my points are 1, -4, and my gradient is equal to -2. So I've got y minus y1 equals m times x minus x1. So I've got y minus -4 equals -2x minus 1. So expanding this out, I get y plus 4. No, I've done something wrong here. Give me a second. No, looks right so far. -2 plus 2. Give me a second. looks all right. Just thought I just made a mistake somewhere here, but let's just keep going and see what happens. So I've got y is equal to negative 2x plus 2 minus 4, which then gives me y is equal to minus 2x minus 2. Oh yeah, no, I was on the right track there. All right, so the reason I got confused with this question was because I normally have the answer schedule next to me, and I noticed that this had been written as y minus 4, and it should be y plus 4 in the answer schedule. But in the end, they kind of like got the answer correctly. Yeah, so anyway, grades wise, what are you going to get? Equation of tangent found is going to get you a merit. Correct derivative found gets you an achieved right there. Let's go to the next question. Oh, this is much better, isn't it? This time I'm going to read the question properly. Because, and see, this is a really kind of like a good little thing to notice about the calculus paper. With the calculus paper, when they have these sketching derivatives, normally they have one where you have to do the derivative, and then two, they would have to do the integration version of it. So it's a good little kind of idea. You know, ideally you should have read the paper from the beginning, so you kind of know where these questions are coming through. And so in this question, I'm actually drawing the derivative, which kind of would send warning bells that, oh, the previous question that we did in question 2 should be integration of that drawing. So anyway, we're here. Let's get on with this one. So looking at this one, I can kind of see that, you know, like you probably will have to draw this at least roughly correctly, I would say. You can't just put a random line here because they've actually given you those values. And if I look at the first one here, I can see that the gradient is actually -1 because 2 across, 2 down, it's -1 is a gradient. And the weird thing is that at the bottom here, they haven't actually given you any scales. And I wonder if they did that on purpose because in the answer schedule, they actually have the scales, right? But then I would just go, if that's, I'd probably do something like that and put that as -1. And then in this case, rise over run is +1. So I'd probably go something like that, where that's 1. And then this looks like 2 and 4. So that's just x squared graph. So if I differentiate it, I'm going to get 2x. So at 2, 1, 2, 3, 4. 2, 3, 4. Something like that. And I should get, what do you call it? A positive, like a 2x gradient for that. So again, you know, like people might be wondering, well, what if I just draw that and don't put the lines in? I would say just be on the safe case, just put those numbers. Just because the way they've done it is, like I know the question actually says like sketch, right? So when they say sketch, usually it means a rough one, but I'd just be pedantic in this case because I've got the numbers. I can kind of clearly see what's happening with the gradient, so I can just draw the gradient straight up as it is. Now this question is worth an achieved, and you need 2 correct to get an achieved. Okay, so going to part 2 of this question is we've got another sketching the gradient, and I guess this is kind of in a weird way they kind of set you up for this question because they shown you what the previous 2 bits look like, so you're just kind of working from there. So looking at these 2 lines, I'm probably going to put 1 and 1 there. So that's going to be +1, that's going to be -1. Now, however, the important thing to notice is this. Now, and I think there was some arguments last year about this particular question coming at level 2 because most of these kind of material gets covered in level 3. But basically, when you have two lines meeting at a point, you can't really have a gradient because, you know, you can't find a gradient at 0. Normally what happens is, if you think about like a parabola, right? A parabola actually does this little smooth kind of curve. So you can actually say gradient is equal to 0. But when you actually have two sharp points, two lines coming like that, very sharp, let me just draw that again. So you've got a parabola kind of like, see, does this smooth thing there, right? So you know that the gradient at the bottom here is 0. But when you actually have two sharp corners hitting it, there's actually no gradient at 0. All right. So because there's no gradient at 0, it's not possible. What we tend to do is, instead of actually putting, we actually put a hollow red thing, and we have to make sure that that blue line is not actually touching that. It's actually not touching it. So it's kind of like this. I should have actually put a, no, it's not going to work, is it? I'm going to try, damn it. We're going to put this as a hole, like a little hole right there. So basically that's just telling that there's actually no gradient found at that particular point. Yeah, kind of weird that you guys get this question at level 2, but it is what it is. Grades wise, gradient function sketched correctly with open circles gets you a merit. So putting these two circles gets you a merit. Otherwise you get an achieved if you just put them as two lines and they kind of like join up. So you achieved is when you don't put those two circles in. Okay, moving on to the next question. So, and again, it kind of sucks that this question follows on, because it says, is it true to say the gradient of the function p of x is 0 when x equals to 0? Justify your responses using the graphs on page 8 and 9. Jeez, which? I guess it would be this graphs here, so justify using that. But to be honest, you know, this is one of those questions where you kind of need to understand, like the first thing you got to say is that, you know, the function, the gradient function is not possible at 0. So that's the first thing I would say. Gradient function, or like gradient function at 0 is undefined. Because when you have those two kind of lines kind of coming in like that, at that corner point, you can't actually find a gradient, and you can't actually have an instant change. Like, think back to that parabola, right? Now the parabola had a smooth kind of change. Instant change is not possible. That's another way of writing it. To find the gradient, right? Now, obviously, I'm kind of saying things here based on my own understanding of this, and it's weird. It's weird because have a look at the answer schedule, and I think, you know, I can't really talk much more about this, but basically, it is not fair because the gradients are not the same. So they're looking at the two gradients from both sides, how one side it's negative and the other side is positive. So if you write that, then you can kind of say that, okay, so that's and achieved for merit is break at 0, and I think I kind of talked about that. And it's really interesting, they've actually talked about drawing a tangent at that sharp point, because at that sharp point you can't really get a tangent. So really kind of awkward question, because I look, personally I hate these explanation questions, right? Because it's like, you know, give me a complex calculus question and I'm happy to do it, but like, don't give me like this reasoning questions, because I don't know, that's just me personally. I get frustrated with these questions because I understand it because I've been doing it for such a long time, but expecting kind of you guys to kind of like pull it out in the middle of an exam under a pressure situation, it's just annoying. Same thing with the whole investigative questions. I just get annoyed by them. But But at the end of the day, that's just one question, and not all of the questions are like that. So we kind of have to kind of just go ahead with it. So anyway, let's go to the much more complex calculus question. Now this is much more workable. All right, so what do we have here? We've got two shapes. We've got surface area, and I guess the important part is right here. Total of 180 centimeters to cut and use for both models. All right. Now, what are we trying to find out? Find out the lengths A and B. So A and B is these lengths here. So this is A, this is B, and cool. We're trying to figure out what the surface area is maximum. So first thing I'm going to write is the surface area equation, which is square root of 3a squared plus 2 times square root of 3b squared. All I've really done here is I've just went the surface area from there plus the surface area from there. That is my equation. All right. Now, obviously, I've got A and B. I need to get rid of one of those letters. And to do that, I am going to use the yellow, because remember that 180 centimeters. So I've got 1, 2, 3, 4, 5, 6. So I've actually got 6A here. And I've got 1, 2, 3, 4, 5, 6, which is this line, 7, 8, 9, 10, 11, 12. 12B. So I've actually got 6A plus 12B equals 180. All right, and this is a much nicer optimization question, even though it looks complex, right? So I'm going to rearrange this, and I'm going to put down A as by itself. So I've got 180 take away 12B, and then A is equal to 180 take away 12B divided by 6. So A equals 30 minus 2B. Once I do that, I go back to my surface area equation and I substitute what A is. So I've got square root of 3 times 30 minus 2B squared plus 2 root 3 B squared. So what I'm going to do is, just to make things a little bit easy for me, I'm actually going to, well, no, I need to expand the brackets. I don't think I can actually kind of get away from this, but if I want to expand the brackets, one quick way that I could do is take out square root of 3 as a common factor. Then I've got 30 minus 2b squared plus 2b squared. Because what I'm going to do is I'm going to expand the brackets, simplify it, and then bring the square root of 3 back in again. So surface area is square root of 3. I've got 30 minus 2b squared, which means I'm going to get 30 minus 2b plus 2b squared. So surface area is square root of 3. I've got 900 minus, what do you got, 30, 60 minus 120b plus 4b squared plus 2b squared. So surface area is square root of 3, 900 minus 120b plus 6b squared. Now I'm going to expand the square root of 3. So I've got 900 times square root of 3 minus 120b square root of 3 plus 6b squared square root of 3. So this is my surface area equation. And then what I've got to do is I've got to try and differentiate it, put it equal to 0, and kind of just keep chipping away at it, all right? So surface area differentiated, I'm going to get, the b is going to disappear, so I've got, just want to double check that we're doing all of this right. So minus 120 square root of 3 plus 12b square root of 3. Yep, that looks right. And we're going to put down is equal to 0 for max. So we're going to get 0 is equal to negative 120 square root of 3 plus 12b square root of 3. Rearranging this, we're going to get negative 12b square root of 3 equals negative 120 square root of 3. B is equal to, B is equal to 10. So if B is equal to 10, we can actually go back and we can find out what A is. And we can see that A, 30 minus 2 times 10, A is also equal to 10. I guess we had to figure out what the question actually asked. The question did ask, determine the lengths of edges A and B, which we've done. Use calculator to justify the surface area is minimum. So to kind of show that, we've got to actually do the second derivative part here. So surface area is equal to minus 120's root 3 plus 12b root 3. And so if we differentiate it a second time, we are going to get 12 root 3. And we can say that since surface area differentiated is always positive or greater than 0, therefore it is a minimum. So grades wise, let's see. So you could solve both for A and B, and justification or gradient function or second derivative test. So for excellence, you would need this, and this. For merit, derivative taken and set to surface area. So this part right here is merit. And for achieved, you're looking at achieved right about there. And wow, okay, that's basically it for this paper. That's question 3 done. So guys, overall, I felt that the paper wasn't too bad. I mean, apart from that, you know, a couple of those annoying questions, those excellence questions, but the other excellence questions were fairly straightforward. And and looking at what is it, the final answer schedule, 19 as a cut score to get excellence, which means that I think it was very much possible to get a nice excellence for this paper if you answered like maybe 8 and 8. So maybe a couple of those excellence questions which were really easy, you probably would have got like 14 points from that. So yeah, no, I think it was more than comfortable way to get excellence. But anyway, look, that's basically it. But my kind of final piece of advice for you guys is anytime with calculus papers, you know, I always say this, like if you kind of not sure about what the question's asking, there's only 2 things that you're going to be doing, either differentiation or integration. With differentiation, always differentiate, put it equal to 0. Most of the time you can walk away with an achieved. And with integration, don't forget that when you actually integrate, you've actually got to put the plus C in it. In terms of people ask this question like, look, do they get marked down if I use a calculator for some of the questions? If it's you're using the calculator for algebra part of it, like if you have a quadratic and you're actually using a calculator to solve the 2 intervals like we did for that decreasing function, it's okay. You can actually just straight up use the calculator. You don't need to show all the working. So yeah, and if you do have any questions or things, just pop it up in the comment section below, and stay tuned for like live tutorials that'll come up later in the year. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.